And this is going on page 32 when we're done. So the words rate of change should make you think of what? Slope, exactly. And so there are different types of slopes. So we're going to talk about average rate of change, but review some good old slope that we know already. And most of you should have seen something that looks kind of like this before. Talked about slope. And even if you've never had me, if you've had algebra teachers on this campus, that you may have done something like this when you talked about slope, because some of them were my students and they did it in algebra and now they're teaching it that way. But what this means, we drew little skiers and it took like all period. But what in general, if you just have that picture in your mind, that means that's a positive slope, that's a negative slope. We should totally not be missing those things anymore. What's the slope of this? 0. And then this is undefined because literally there is nothing there, right? So if that picture is in your mind with slope, you can figure important things out before you ever start so you don't make sign errors. Because it's not that you don't know that it's positive and negative, but sometimes sign errors happen and that can help you either know that you have one or not make one. When we look here, what letter do we use for slope? M, right? And then what are the magic words you learned when you first learned slope? Well, yeah, but they're the words, not like the formula. Rise or run. And so they've given us 2 points, and we're supposed to find the slope between those 2 points. So I know that the first thing I think about when I look at this is that this slope is going to be what? Positive. So I don't have to worry about it. Then I can count my rise over run. I go up 3 and over 4, so it's 3/4. And we should never miss anything like that, like ever, right? Okay. So look at number 2. The first thing that should pop in your mind about slope is it's negative, okay? And then I can count. It gave me 2 points. My rise over run, I rise what? 8. And I run 4. So that means this is -2. Everybody good with that? All right, so look at 3. The first thing that should pop in your mind is what? 0, right? 0 slope. I don't have to count. If you really want to count your rise over run, you rise 0 and you run 8. You still get 0, but you totally don't even need to do that, right? Never miss anything like that, like ever again, ever. Then when we have actual ordered pairs, our big boy and girl slope formula is what? Good. Delta y over delta x. Delta should be familiar to everybody because you should have used it in chemistry. You're definitely going to use it in physics. You should have used it in algebra and algebra 2 for slope. But delta y over delta x. So when I go to do this, slope is, I'm going to change my change in y. So -7 minus 3 over -5 minus a -9. What's -7 minus 3? -10. And then -5 minus a -9? 4, +4, right? Which means that my slope is -5 over 2. Do I make that into a decimal? No, never. Okay. We'll do one more. You should be able to do this in your sleep, but we're going to do one more anyway. Slope is change in y, so -4 minus a -1 over -7 minus 2. Sign errors are what would kill you here. It's not that you don't understand the concept, but forgetting to write one down, not that you don't know positive and negative integers, but just sometimes not writing it or just doing it wrong. So what's -4 minus a -1? -3. And -7 minus 2? -9. So your slope is 1/3. Right? Piece of cake, yes? Okay. So the only thing that you have used slope on are lines, right? You find the slope of the line. That's what you're told to do. And that's because this type of slope, there's different types of slope. In this case, you can only use it on lines. Now, one thing you do in Algebra 1, they'll give you some random graph and you have to come up with a story. Did y'all ever have to do that? Like, well, I walked, 5 miles to the park and then I stayed at the park for 10 minutes and then I walked back or whatever. And you had to kind of give a story of what was happening with the graph. Did y'all ever have to do that? Okay. Some of y'all are saying no. Like the morning classes were like, yeah. Well, that's something they used to do. I don't know. I haven't taught Algebra 1 in forever. But anyway, do you see what I'm saying? Like if it was something like this, like, well, I walked and then I turned and then I stayed and, they were trying to get you an idea of distance or whatever. But one thing, maybe they stopped doing that, because one thing that it doesn't take into account is your speed. If I'm going to walk from here to the park or ride my bike or drive, am I going at the exact same speed the entire time? No. When you take off from a red light, it don't matter how fancy your car is, you're not going from 0 to 60 in 0 seconds. It doesn't happen instantly, right? You might get there faster than other people, but it's not instant, right? So it's the rate of change isn't constant until you're going and you hit cruise control, and when you got your cruise control set, then you're at a constant rate of change because your rate is 40 miles per hour or whatever it is. Does that make sense to you? So that's constant, and that's what your line would look like. Otherwise, it's just like increasing or decreasing, kind of like when you think about exponential, like it's increasing slowly and then it gets really fast. So linear stuff, what we have here, linear is always a constant rate of change. But if you think about like an exponential, that rate of change changes because the speed changes, and your speed is like one example of what your rate of change could be, okay? So we're going to look at average rate of change. What do we do when we don't have linear functions and we need a rate of change? So it says for functions, the slope is constant between each pair of points. So for nonlinear functions, the slope changes between different pairs of points. Because of this, we find the average rate of change. So on these top ones, these top three, they put 2 points on there for us. We use those 2 points, we found that slope. If we wanted to be rebels and pick 2 different points on that line and find the slope, would we get the same answer? Yeah, if we did it correctly, we get the same answer because it doesn't matter what points I pick, right? When you have something that's not a line, it matters. Because if I pick these 2 points and I find the slope of that line, that's going to be different than if I pick like these 2 points, right? I would have a totally different slope. And so I could want or need the average rate of change for a lot of reasons. If when you go to fill up your car and you want to know what your gas mileage was to see if, if it was worth getting a different kind of gas or whatever, and know how much you're actually spending, you could realize that you got, 5 miles to the gallon. That's terrible gas mileage. You get 25 miles to the gallon. That's decent gas mileage, right? And so that's your average. That doesn't mean at any given point that's what your fuel mileage is, right? Because you could be getting 80 miles to the gallon at some point, or 3 miles to the gallon because you're accelerating. But all that just it all just averages out because you can't have it exact all the time. Or maybe I want to know what. I doubt you would want to know your gas mileage at one single point, but something like that you might want to know instantaneously. If I wanted to know what the rate of change was at this point, not at between these 2 points, but literally right here, what was happening, then that's called instantaneous rate of change. I only have 1 point. It requires calculus for you to be able to do that. We could get a pretty darn good estimation, though, if we found 2 points right on either side of it and then found the slope of that line. It would be pretty close to what the slope would be right at that point. Would you agree with that? So we can use average to get closer and closer to instantaneous, or we can use average just because average is what we need. And so this says the average rate of change of a function between 2 points is the slope of the line that passes. You know how to find slope, so this isn't hard. The average rate of change between these 2 points right here on this graph is the slope of this line. This line intersects that parabola at 2 points. A line that intersects at 2 points is called what kind of line? Okay, tell me, what is a tangent line? It intersects at exactly 1 point. So actually, instantaneous rate of change is the slope of the tangent line at the point. So there's a tangent line here that would intersect only at that point. I can't draw it with this stupid marker, but if I intersect at 2 points, it starts with an S. Don't completely break my heart. Come on. S-E. C-A-N-T, secant. Oh, Lord. Secant line. That's geometry, boys and girls. Regardless of what level you were, who your teacher was, and where you took it, you should have learned about secant lines. Clearly, I did not do a good job of teaching that because nobody has a clue what they are. But it's a secant line, all right? So we got tangent lines, exactly 1 point. Secant, that's a secant line. It intersects at 2 points, okay? So average rate of change isn't the slope of the line itself, because it's not a line. It's the slope of the secant line between those 2 points. Okay, instantaneous would be the slope of the tangent line, but we're not there yet. So the formula for the average rate of change. Okay, now the words rate of change are still in it. It's still slope, so it's still going to look a lot like slope. And you have an interval, A to B. That's what this A and B is. That's where the points are. It's our x values. So I'm giving you a closed interval, and I want the average rate of change on that interval. It's going to look like this. We still use m for slope. Little SEC is a subscript, meaning the slope of the secant line, equals f of b minus f of a over b minus a. That looks like a whole lot like the first slope formula you ever learned, and not the big boy and girl slope formula, right? But we're using f of b instead of y, and that's kind of nice too, because then you can make sure it lines up so you don't get things flipped around. It's still y minus y and x minus x. Still the change in y over change in x. But it looks a little bit different because you have to actually go and find function values. Okay, so this is your average rate of change, and it's for a secant line. We all good? So if we can find slope, we can totally do this. Let's look at some examples. So it says, given the function graph below, find the average rate of change on each interval. So they've given me the interval from -2 to 1. So that's my a and my b that would go in the denominator. So I have to find the function values. So I have to find f of -2, and I have to find f of 1. And we're not guessing off the graph. We don't have to estimate. They're going to be whole numbers. It's going to be fine. So what is f of -2? No, but close. It's 1. It's very close to that, but it actually intersects right here at 1, because the graph is accurate there. So at when x is -2, y is 1. What is f of 1? -8. Okay. We all good? They count fast? Is that what you're saying? Yeah, it's all good. They were probably already counting. All right, so now that I've found those things, I'm going to find the slope of my secant line. That's going to be f of 1 minus f of -2 over 1 minus a -2. So I've already found what I need, because I found it first instead of writing this down first. F of 1 is -8 minus f of -2, which is 1. What's 1 minus a -2? 3. So this gives me -9 over 3, which is -3. And that is the slope of my secant line. Okay. Everybody okay with that? Easy enough? You're still just finding slope, really. You just have to know what it means and how to write it. Okay, so now let's do this one. We're going to have to find f of 0 and f of 4. So what is f of 0? -7. What is f of 4? 1. It's 1. It looks pretty close there too, but it actually crosses right there at 1. So now, before we even did number 7, just looking at those 2 points, what was something we knew about the slope? Positive or negative? Negative, because you see the 2 points, it's got to be negative. Most people probably didn't even think about looking at that, but that way you can make sure your sign's right. So this one, I know my answer is going to be what? Positive. And even though I know you're capable of counting on the graph, you're never going to be able to pass like this example, and that's not the point of this, so we're not counting on the graph. But so the slope of the secant line is f of 4 minus f of 0 over 4 minus 0. So f of 4 is 1 minus a -7 over 4. What's 1 minus a -7? 8. 8 over 4 is 2, and that's the slope of the secant line. Any questions at all at this point? Awesome. All right, let's look on the back, because on the back, we don't have any pictures. And we are going to start with number 10. I'm going to skip number 9 just because there's other ones I want to do. We're not going to do all of them. You don't have to write tiny, but if you have big, bubbly handwriting, you might want to tone it down a little bit. I don't want you to be mad at me when it doesn't fit. So again, just kind of watch your space, and if I haven't used up half the space, make sure you haven't either. All right, so this says find the average rate of change, which is telling me slope of the secant line, just like rate of change told me slope, of each function on the given interval, and then we're not rounding our answer because we don't even have a calculator, and we won't have to estimate on anything. There's like one that comes out to a fraction, but it would be a fraction. Okay, So here, they give me the function, they give me the interval. So in order for me to do this, I have to find f of negative 9. I'll do that one first, and we'll find the other one. So I substitute that in. 2 times negative 9 squared plus 28 times negative 9 plus 93. Now, this is going to be a lesson not only in average rate of change, because that's slope, so you're pretty much going to get that, but also in how to handle numbers and not freak out, not make your life harder, not necessarily be a math whiz in your brain either. I'm not saying that, but to not let this stress you out quite so much. So negative 9 squared is what? 81. Times 2 is 162. We really shouldn't have any issues with that. Now this 9 times 28, we're going to talk a couple of different ways here. And I know some of you already think this way, but not everybody, and people need to hear this. First of all, when I multiply that, it's going to be positive or negative? Negative. So I'm going to write that down so I don't even have to think about the sign now so I don't forget about it when I'm doing my numbers. I got two options here. Well, you got multiple options, but one thing you could do is you could multiply 28 times 10 and then subtract something. You with me? And again, some of you kind of already do things like that. What I realized this morning was some people knew to do that, but then they never knew which one to subtract. So here's what you want to be thinking about when you do this. It's 28 times 9 is what I want. If I do 28 times 10, that means I'm going to have 10 28s. I don't want 10 28s. I only want what? 9 of them. So I do 10 times 28, which is easy, right? It's 280. And I only want 9, so I'm going to have to subtract 28 from that, right? And then how you subtract that, it's up to you too. You could subtract 30 and add 2 back. Or what I usually do, because it kind of works every time, is I subtract 20 and get myself to 260, and then subtract 8 and get to 252. And I'm telling you that because this is the kind of subtraction y'all mess up the most. You give me answers like 262, right? Because you just subtract the 2 and the 8, and then, oh, well, this 8 becomes the 2, and it's just wrong. So subtract 20, get yourself to 260. 8 more gets you to 252, right? If that's not the way your brain's going to work, that's fine. Instead, you could do 9 times 20, which is 180, and then 9 times 8, which is 72. And when you add those together, you get 252. But here's what I'm telling you about all of this. If you never, ever practice this, except when I make you pay attention to what I'm doing up here, your brain's never going to get better at it. So I know I'm not stupid. I know that when y'all leave here, there are plenty of you that the first thing you do is grab a calculator because you're like in panic mode because you didn't get to have one for a whole class period. And but not all of you do. Some of you may sometimes, whatever. But you need to, it doesn't have to be cold turkey. You don't have to take your calculator and throw it in the trash. You need to learn to let it go, meaning that you need to try the things I'm telling you. Calculator sitting right there makes you feel better, great. After you have tried not using it, use it to check yourself. And if you messed it up, fix it, whatever. And then try the next one. And the more you try it and you keep checking yourself and you're right, you're not going to need that calculator anymore. And you're going to get better at it and faster at it. And it's going to help you with a bazillion other things. But you have to practice. You absolutely have to. Because the people that can do it, and some of y'all think they're just geniuses. Well, some people are just born like that. That's true. But they also think that way most of the time, and it just gets better and faster, and it will for you too. You may never be a math whiz. Who cares? You don't have to be. But you have to be more confident in it and not let it freak you out. Okay, so then that's plus 93. Now, here's the next thing I would do. I'm gonna combine these two, so I'm still going to have that plus 93 out here. And if I combine these two, I know that it's going to be negative in the end, right? So I have a negative something, and now I don't really care about the signs because I'm still subtracting, and you just take the sign of the larger one. So I'm just going to kind of write some stuff out over here, which you may or may not write when you're actually doing it, but I want to make sure you can follow my thought process. If I'm going to do 252 and subtract 162, the first thing I would do is take the 100 away. So now that's 152, and I'm left with 62. And then that 52, I'll take that away, and so that leaves me 10 more, and that gets me all the way down to 90. Do you see how you did it in pieces? And you may think, well, that takes longer. But the more you do it, those pieces go pretty quickly. You don't even really realize you're doing it. But it's kind of like how you think about money and how you would make change, things like that. It's 90. I didn't have to borrow anything. I didn't have to carry anything, nothing like that. It was just a matter of taking apart bits and pieces depending on what makes sense at that time, okay? I'm, again, not saying you have to do it my way, not saying you have to do everything in your head, but I know there are plenty of you that really struggle with just making it make sense and not having insane work all over the place that makes no sense. So when I combine those, then I get f of negative 9 equals 3. Okay, and I'm going to underline it so I don't lose it in my work. Then I'm going to have to do f of negative 7. That's equal to 2 times negative 7 squared plus 28 times negative 7 plus 93. Negative 7 squared is 49 times 2 gives me what? 98, because you could do 50 times 2, which is 100, and subtract 2. Now here, for this one, again, I know it's going to be negative. I wouldn't multiply it by 10 and then subtract 3 28s, because I think for myself, subtracting 3 28s is going to be way harder than anything else I would do, because it's just not a nice number to subtract, for me anyway. Instead, on this one, I would do 7 times 20, which is 140, 7 times 8, which is 56. Of course, you have to know your multiplication facts too, by the way. And that right there gives you 196. And then plus 93. Last person in my 3rd grade class to learn my multiplication facts. I have a very bad memory, but I remember that, so I know I was traumatized. But I finally got them. So even if it takes you a while, you'll get them. All right, so negative 196 and 93. I'm going to combine these two first. What does that leave me with? Negative 103, and then a negative 103 and a positive 98 is going to be a negative 5. You don't always have to go left to right. You look at it and decide which ones are easier to combine first. Everybody with me? Okay, so there's a little bit of an arithmetic lesson to get that, and then we have to actually find the slope of our secant line. That's f of negative 7 minus f of negative 9 over negative 7 minus a negative 9. Minus a negative 9. So f of negative 7 is negative 5 minus 3 over, can't even read that with that. Negative 7 minus a negative 9. What does that give me? 2. So that gives me a negative 8 over 2, which means the slope of my secant line equals negative 4. If you look at what we just did, substituting those in to find, I mean, the function notation, okay, that's high school stuff, whatever. But if you just substitute in the negative 9 and have to work it out, that's order of operations. That's way pre-algebra, right? Just knowing how to, whatever, and knowing how to multiply and divide. And then, yeah, this is slope, and technically, average rate of change is pre-cal material, but it's still just slope, right? There's really nothing complicated about what we just did. Is there a whole lot of places for you to make mistakes? Yes, and that's why you got to be able to read your own handwriting and actually keep track of what you're doing. Any questions? All right, let's look at number 11. We're going to find f of 4, and that's going to give me 4 cubed minus 2 times 4 squared minus 9 times 4 plus 1. 4 cubed. Now, you should know what 4 cubed is because y'all did the cubic stuff last year, but let's say we don't, because I just want to talk about 4s anyway. If I square 4, I get 16, so I need to do 16 times 4. Multiplying anything by 4, the easiest way to do it is to double it and then double it again. So that's going to give me 32, and then I double that and I get 64. And I didn't actually multiply by 4, but again, it's knowing how the numbers work. Minus 4 squared is 16 times 2 is 32, minus 36 plus 1. So for this one, I'm going to combine these two first. So negative 32 and negative 36 is a negative, what? 68. So negative 68 and a positive 64 is negative 4 plus 1 is negative 3. And if you need to jot numbers down along the way so you don't forget what you just thought in your head, then do that. I mean, you can write stuff down. Now I need to find f of 7. That's equal to 7 cubed minus 2 times 7 squared minus 9 times 7 plus 1. 7 cubed. Chances are pretty good you don't just know that one. It's fine. 7 squared is 49. We're going to multiply that by 7. Well, this is one where 7 times 50 is pretty easy, right? What's 7 times 50? Are you cheating over there? He did. I heard it. Is she listening to me? She's a stalker. Okay. It's creepy. Tell her she was wrong anyway. Okay, so what's 7 times 50? 7 times 50. What is it? 350. Okay, once I do 7 times 50, then what do I have to subtract? 7 or 50? 7. Because I only want 49 sevens. This is 50 sevens. So I take 1 away, and what do you get? 343. Not whatever she said, which was not 343, by the way. Or you could do 7 times 40 and 7 times 9 and add them. 7 squared is 49 times 2 is 98. And then minus 63 plus 1. Now in this one, I would start by combining these two. Notice I'm not always doing the first two. You look at it and think it's easiest to do first. That should always be your question. So when you do these right here, what I would do is when I'm going to subtract that, take 43 away first. So I get to 300. That gives me 20 left over. So that's 280. Make sense? So I've got 280. And then I have to subtract 98. Well, actually, let me do this. I get 280. And then negative 98 and a positive 1 is negative what? 97. So in this case, you could subtract 100 and do what? Add 3 back. So f of 7 is going to equal 183. Okay. Are we all good? So now I come in here and do slope of my secant line. That is f of 7 minus f of 4 over 7 minus 4. That's 183 minus a negative 3 over 3. 186 over 3. Now, I'm going to ask a question, and I want you to be honest, because I know not very many people in here are going to raise their hands, and it's okay if you are one. It doesn't mean that you're stupid. Raise your hand if you don't know how to just look at a number and know whether or not it's divisible by 3. Is that anybody? I need you to be honest. Okay. If you take the digits and you add them together, so 1 plus 8 is 9 plus 6 is 15. If that number is divisible by 3, then this number is divisible by 3. The 15 doesn't mean anything for your answer, but that way I can just look at it and know. I don't have to try it, right? I could try it, and if it's not, then I wasted my time or confused myself. If I know it's divisible by 3, I can get my answer. If I know it's not, I'm done, and that's my answer, right? But it is, so that's going to give me the slope of my secant line is going to be what? 62. Okay. Also, in case you didn't know that, every multiple of 9, you add the digits, they equal 9. So just keep that in mind up there. Think about that, all of them. All right, let's jump to 15. We're going to jump to 15. I want to get part of 15 done at least. A company's total cost in dollars to manufacture X units is given by this. Find the average rate of change in the total cost for the first 200 units. All right, so it was still average rate of change. The one thing I didn't get here that I got on the ones above there was the interval. Like they told me, but it's not written as an interval. So if I want the average rate of change on the first 200, what does my interval look like? 0 to 200. Okay, good. So I have to find those values. I'm going to find C of 200 first. That's going to be 0.05 times 200 squared plus 40 times 200 plus 1200. Okay? And then I know you're already thinking, and we don't get a calculator, and she's so mean, and those numbers are just so big. It's actually safer without one, because more mistakes are going to be made on the calculator on this, because you're not going to type in all the zeros sometimes, or you don't read them all back off right, or whatever. This is not that bad. Let's look at what's happening here. We've got 0.05, and then I've got to square this. Well, what's 2 squared? 4. And then, I know, real hard question. Then how many zeros? Since I squared 200, 4. Okay, so it's 40,000. Plus 4 times 2 is 8. And then how many zeros would I have? 3. Plus 1,200. Everybody with me so far? Yes. Now, we're not going to do any multiplying here. Okay? It's another one of those times where you look at it, we've got all these tools in our tool belt, which one do we want to use? Thinking in terms of money is great. That being 5 cents doesn't really help me. But that 0.05 could also be what percent? 5%, right? Okay, so 5% is not that bad, but 10% is really easy. Is it easy to find 10% of something? What's 10% of 100? 10, because you just move the decimal place over once, right? So we're going to start by just thinking about 10% of 40,000. So what's 10% of 40,000? 4,000, because you just move the decimal place over once. You with me? Now, if I wanted 5% of 100, I found 10%, it's $10. How do I get 5%? Divide it in half. Half of 10% is 5%, so the 5% that I actually want is just 2,000. You see how that required like zero work, just an understanding of how numbers work? Yeah. I wasn't multiplying decimals and moving decimals and losing zeros and doing weird things that mess us up. And then if I add 8,000 and 1,200, that gives me what? 9,200. And then 2,000 plus 9,200 is 11,200. Yes, still not that bad, right? And that is that C of 200. Everybody with me so far? Now admit it, that wasn't nearly as bad as you thought it was going to be, right? Okay, so then I've got to find C of 0. That's going to be 0.05 times 0 squared plus 40 times 0 plus 1,200. So C of 0 equals what? 1,200. So now I have to find that average rate of change. The slope of my secant line is going to be the C of 200 minus C of 0 over 200 minus 0. So that gives me 11,200 minus 1,200 over 200. What's 11,200 minus 1,200? 10,000 over 200. Dividing by like this is great because you can just knock out those zeros, right? You get 100 divided by 2, which is 50. But I can't just leave it like 50 because this is an application problem. I have to have some sort of, say that's the slope of my secant line. I mean, it is, but they didn't say find the slope of the secant line. So what type of units are on here? What would it look like? Just dollars? Okay, so if it was just dollars, that's my Y value. That's the cost. But this is a rate. Per hour, dollars per unit, because I heard that. So this is dollars per unit. So if you have found a slope of some sort, a rate of change, most of the time the units are going to sound like something per something or something like that. Okay. Any questions at all? All right. I want to get 16 just started. We're just going to start it and then we're going to finish it tomorrow. So a ball is thrown straight upwards so that its height is h of t in feet, and it's given by this equation. That should look familiar. Totally did that in Algebra 2. Find the average rate of change in the height of the ball from when it reaches its maximum height until when it reaches the ground. So I have to come up with the interval. It's from when it reaches its maximum height. Do I know what that time is right now? No. To when it hits the ground. Do I know what that time is right now? No, and it's not 0 because that's where it starts, not where it hits. So I got to figure both of those things out. So how do I find the maximum height? I'm going to go tell all of your Algebra 2 teachers. Does that look familiar? Oh, yeah. Okay. So negative b over 2a, that's negative 80. Oh, I appreciate that. Negative 2 times negative 16. So that's going to give me negative 80 over negative 32. Now, I know some of you can reduce that quickly. Other people, you spend time trying to find the biggest number to divide. Stop doing that. Do it in 20 over 8, 10 over 4, which becomes 5 over 2. If you can do it and not do that, that's fine. I'm not saying you have to do it that way. You don't even always have to write it all down. You can kind of just step through it in your head, so it's not that big of a deal. So we're starting at 5/2. Okay? That makes sense? All right. So we're going to start here tomorrow and finish that up.